Hello ladies and gentlemen, and welcome back for another video for Chem-MrT. And today we're going to be looking at the noble gases, or group 0 in the periodic table. And this is from topic 1 on atomic structure in the periodic table. So we're going to be learning about today where we find the noble gases, why they're called that, the electronic structure of the noble gases and how that relates to their reactivity. And we're also going to have a look at the trends in boiling point and atomic mass and the trends in density within the group. So, first of all, group 0, the noble gases. On your periodic table, they're on the far right hand side, and here they are highlighted in red, and they've got a little red circle around them, and we've got helium, neon, argon, krypton, xenon and radon, and they are our noble gases. Now, the noble gases weren't discovered until about the 1880s, the late 1880s I believe, until about the 1900s. The reason is they're super unreactive, which is also called inert. So inert, it means they don't react, and that's why they got the name noble gases, the idea being that they're very noble, they don't take part in things, they stand aside and they're aloof. So they're inert, they're noble gases. Argon was discovered first, then it was named after an ancient Greek word for lazy, because it doesn't do much, it doesn't do any reactions, and this is the unreactivity is why it took them so long to figure out that they existed, because they don't react with oxygen, they don't react with metals, they just float around in the air. It took quite a while to figure out that they were there and to start isolating them. And the others were discovered shortly after argon, so after the discovery of argon people thought, oh well, maybe there's other gases to discover, and went on to discover those in short effect by cooling air down to very, very cold temperatures and discovering the other gases. Now they don't form compounds, certainly not under normal conditions, so anything that you will encounter at GCSE or even A-level chemistry, you will never encounter a compound of a noble gas. It is possible to make some of them react, but it is very, very difficult. And they are always found as single atoms. For example, helium as a gas, neon as a gas. You will notice there's no subscript number, so it's not like oxygen, which is always a diatomic gas, so O2, or chlorine, Cl2. It's just helium, neon, He, Ne, Ar for argon. Okay, never as a compound in GCSE chemistry. So now on to electronic structure. And here we've got helium, neon and argon. So helium is period 1, so it's got 1 shell. Neon is period 2, so it's got 2 shells. Argon is down in period 3, so it's got 3 shells. And here's the information we'd get given on the periodic table. We've got our mass number at the top, the largest number, and we've also got our proton number, or our atomic number, at the bottom. And this tells us not just the number of protons in the atom, but also the number of electrons. So helium's got 2, neon's got 10, argon's got 18, so we can start populating that. Now we know the first electron shell can only hold 2 electrons. So in helium, those 2 electrons fill the full outer shell. In neon, we've got 10 electrons. So 2 go in the first shell, and that leaves us 8 left. So those 8 go in the second shell, and this is the notation how to write it down. So 2, 8. This is the electron configuration, showing us how many electrons in each shell. Argon has got 18, so you can probably figure out that we're going to have 2 in the first shell, 8 in the second shell, which takes us to a total of 10, and then 3 in the outer shell, 8 in the outer shell, sorry, so 2, 8, 8. So what do you notice about all of these? And the pattern carries on down the group. What you notice is they've all got full outer shells, and that full outer shell is what makes them unreactive. So when an atom reacts, it's trying to get a full outer shell. The noble gases have already got a full outer shell, so they're not interested in reacting. They don't want to lose any of the electrons, and they don't want to gain any more, and they actively resist. Well, they don't actively resist, but they resist that process, so they don't gain electrons very easily, neither do they lose electrons very easily. So full outer shells, and that's what makes them unreactive. It's also why the halogens, which have got 7 electrons in the outer shell, and the alkali metals, which have only got 1 electron in its outer shell, react so readily, is because they want to lose or gain an extra electron to get a full outer shell. And that's why they're so reactive. Now the trends in group 0. As we go down the group, the atomic mass goes up. So as we go down the group, starting from the top in helium, moving our way down to radon, the atomic masses go up. And this is because we're going to be adding more protons and neutrons into the nucleus, and they are what gives an atom its mass, or certainly most of its mass. This also means that the density increases as we go down the group, so they become more dense as we go down the group. As we know, helium floats. Radon doesn't. It would sink like a balloon, lead balloon, sorry, so it literally fall straight down. As we go down the group as well, the boiling point increases, so it takes more energy to boil them. And here are the boiling points. So helium at the top of the group has got a boiling point of minus 268.6 degrees Celsius. So that means if you want to turn it into a liquid, you've got to cool it down to that temperature, or below that temperature. Radon, though, boils at minus 61.5 degrees Celsius. So any temperature below 61.5, radon will be a liquid. Above minus 61.5, it's going to become a gas. So the boiling point increases. These temperatures are all going up. Be aware that it's a minus number, so we're going from a very, very low number, we're going from a number below 0, and we're getting closer towards 0, so the boiling points are increasing. Now we're going to have a look at some of the uses of group 1 elements, and there are quite a few uses, and you might have come across some before. So helium is lighter than air, so it can be used to float blimps and airships. So here's a Goodyear blimp that some of you might have seen around, floating around. It's floated with helium gas. Now the Nazi government on the Hindenburg used hydrogen, which is not a noble gas and is very reactive, and that's led to the disaster where the Hindenburg burnt down. Now helium won't burn, so it's perfectly safe. It's also the same thing that you find in party balloons that float. Also, because the noble gases are unreactive, they are used in filament light bulbs to stop them reacting with oxygen. We no longer see so many of these. It's still possible to get them in certain places, like maybe inside your fridge or inside your cooker hood or oven. You get a filament light bulb and they tend to be filled with a noble gas, and that stops the filament, which is made out of metal, reacting with oxygen and burning, because these filaments can get very, very hot, like over 1,000 degrees Celsius. More uses, so we can use various group 0 gases, various noble gases in lasers, and that will give different colours and different effects for the laser. You can also use them in neon lights, and different combinations of gases or different gases will give different colours, and here we've got them here. So we can see helium, neon, very distinctive red colour, argon very purpley, krypton and xenon, and you can kind of mix and match different combinations of these gases to give you different colours as well. Quite a fascinating bit of science. Gradually falling out of favour as LEDs become more popular. So, summary, only a short one today. Noble gases are found on the far right of the periodic table. They are inert, which means they're unreactive, hence the name noble gases. They're inert because their outer shell of electrons is full, so they either have 2 in the case of helium or 8 in the case of the other ones that you need to know for GCSE. They do not form compounds because they're unreactive, they're inert. And the boiling point, masses and densities increase as we go down the groups. And finally, coloured neon lights, lasers, helium balloons, blimps, airships, things like that are all uses of noble gases. There are many more, including they use it in welding to stop the hot metal reacting with the oxygen. For example, if you're welding iron, you don't want the hot metal to the hot iron to react with the oxygen and form rust. Okay, I hope you've enjoyed the lesson. I hope you found it useful. Got lots of good notes. Please remember to like and share and subscribe. And thank you very much to returning subscribers, returning viewers, and hello to any new ones. It's good to see you all here. And hopefully we'll be seeing you all again soon. Okay, take care. Bye-bye.